All right, you guys, so now we're going to go ahead and do lesson 6.7 here, and this is the composite functions. So once again, we're going to be given two different equations, and we do have to solve for them using substitution here. So let's go ahead and get started here with definition of what composite function is. Composite function in this case, guys, talks about when one function is inside another function. And we're going to go ahead and see that right now. So starting off with example 1 here. Example 1, we're given f of x equals a 3x minus a 1 and g of x equals 2x cubed plus 2. Goal in this case is to find f of g, or g of f of 1. So that's how you read it. G of f of 1. So that's how you read it, guys. G of f of 1. All right. Now, in this case, guys, with this here, whenever you're working with composite functions, you do want to go ahead and work inside out. So we're working with what's inside first, which is f of 1. So what f of 1 in this case is indicating is that whenever I see an x in f of x, I need to substitute it with the 1. So here is my f of x. So f of x in this case, once again, it's 3x minus 1, or in this case, 3 times 1 minus 1. So let's go ahead and bring down f of 1. 3 times 1 is 3 minus 1. 3 minus 1 in this case, guys, is going to give us a 2. So now we actually already know what f of 1 equals. We know f of 1 in this case equals 2. So this here is actually going to become now g of 2. Once again, it's replacing f of 1 with 2, because that's what we found out down here. Now, once again, g of 2 is telling us that wherever we see an x, we're going to substitute it for a 2. So let's go ahead and do that here. And I have g of 2 equals 2 cubed plus 2. 2 cubed in this case, guys, is going to give us 8. And 8 plus 2 is going to be 10. So our answer in this case with g of f of 1 is going to equal 10. Our answer in this case, guys, is 10. All right, so let's go ahead and work on the next one. And here is the next one. And in this case, example 2, we have g of x equals x plus 4, and h of x in this case equals x squared minus 2x. Our goal in this case is to find f times g of negative 2. Now, starting off in this case, guys, when you're given this expression here, it's actually the same thing as saying h of g of negative 2. So they wrote it a different way, but once again, this could actually be rewritten in this format. All right. Now, once again, we're starting inside out. So we're starting off with the inside first, which is g of negative 2. So g of negative 2, it's telling me that with g of x, wherever I see an x, I'll be substituting it for a negative 2. So negative 2 plus 4. So in this case, guys, what is negative 2 plus 4? And that's actually going to be a positive 2. So g of 2 in this case is going to become a 2. So in this case, for this problem here, this is now going to become h of 2. Once again, because g of 2 now equals 2. So it's the same one there. So let's go ahead and go to h of x now. So in this case, I have h of 2 equals a 2 squared minus 2 times 2. All right, and h of 2 here is going to equal 2 squared is 4, and 2 times 2 is 4. Now, in this case, guys, what's 4 minus 4? 4 minus 4 is 0. So our answer in this case with h times g of negative 2 is going to be equal to a 0. And that is our answer. All right, let's go ahead and move on to this next one. And now on this next one, guys, we have f of t equals t minus 2 and g of t equals t squared plus 5. And we want to go ahead and find g times f of t. So starting off, guys, I do need to rewrite this expression here. And this is actually going to become g of f of t. Just like that. And in this case, they're actually not giving us a value for the variable. They're not giving us a value for t. But we do know what f of t equals. F of t in this case, guys, equals t minus 2. So I could actually rewrite this here. So I could actually rewrite this one as g of t minus 2. So what this here is telling me is that wherever I see a t in g of t, I have to substitute it for t minus 1. So let's go ahead and do that here. And let me actually just move this around. Let me actually move this on this side. And let me actually bring an arrow down here. So this is actually that there. Okay. So let's go ahead and do that with g of t now. So that's going to be, instead of t squared, it's going to be t minus 2 squared plus 5. Now, in this case, guys, we do need to expand this here. So that's going to become t minus 2 times t minus 2 plus 5. Now, once again, in this case, guys, I am actually going to be using the area model. So in this case, with the area model, we're going to go ahead and just build a rectangle here with 4 squares in this case. It's like a Punnett square kind of. So multiplying these out, t times t in this case is going to give us t squared. And then t times negative 2 is negative 2t. T times negative 2 is negative 2t. And negative 2 times negative 2 is a 4. In this case, only numbers we could combine are these two. So that would become a t squared minus a 4t plus 4 plus a 5. Don't forget the 5. We have to bring it down. And in this case, the only things we could combine are the 4 and the 5. So this reduces to t squared minus 4t plus 9. So our answer in this case for g of f of t is going to equal t squared minus 4t plus 9. And that is our answer. All right, so once again, we're doing basic substitution here, guys. We're working inside out with the composite functions here. Now, I do want to go ahead and move on to just a few more examples. For this one, guys, it is optional for you guys to write down just because it's a graph and a table. So we could simply just click here. So in this case, we are given 2 graphs. We're given f in this case, which is this one here, and we're given g, which is the one on this side. So in this case, they are asking us to do f of g, or f times g of 3. Once again, another way for us to rewrite that expression is going to be f of g of 3. Which means we're going to go ahead and work inside out first with g of 3. Now, what g of 3 in this case is telling us, guys, g of 3, it's telling us that wherever, we basically have to go where x equals 3 and see where it meets our graph of g. G in this case is the line, it's the one in purple here. So x in this case equals 3 here. So where it meets the graph is at negative 2. So our answer here is negative 2. So once again, we already know what g of 3 is. So now I can find f. And it's going to be f of negative 2. So this is telling me once again to go where it equals negative 2 at x. And then see where it meets my graph in f, which in this case is a 6. So our answer up here is going to be a 6. All right, now let's go ahead and do that with the table here. And in the table, guys, they are telling us to do h times g of 0. And they are giving us 2 tables of g of x and h of x. So starting off, h times g of 0 is the same thing as saying h of g of 0. So first off, we are going to be looking for g of 0, which means look at your table with g and go where x equals 0. X in this case equals 0 here. So our answer is 3. Answer there for g of 0 is 3. So now that becomes the value for h. It's going to be h of 3. So let's go ahead and take a look at h in this case, where x equals 3. So our answer here is going to be a 5. So final answer here, guys, is indeed a 5.